In this video, we're going to review transformations, but we're going to look at it with respect to polynomial functions. First, we're going to look at, just generally speaking, a general function that if you see I just wrote f of x equals f of x. I haven't even told you what kind of function that is because everything follows that pattern no matter what the function looks like. Everything in this first column is considered parent functions, and then everything that we do over here will be transformations to that function. So the first thing I want to point out is if we're doing a horizontal transformation, that means we're going to be looking at a transformation of the function either left or right from where it originated from. The other thing that you need to keep in mind is it's going to be in the opposite direction from the sign that you see. Okay. The letter that we use for horizontal transformation is the letter H. So since H goes in the x direction, H is always with the x. So I'm going to write that down as just a note. Always with the x, because it's going in an x direction. So what do I mean by that? So if I take my function f at x, in the parentheses, I'm going to move my x so many degrees or so many positions either left or right. So that's what that would look like as a parent function. From the parent function, general function. I want to move it left 3. So my h, this has to do with my h. So if I'm going to move it left, that means that this is going to be x plus 3 is how I would write it inside the function. So that is a horizontal shift. Now we're going to add on and we're going to do a vertical shift to that. So vertical shift means up and down. So this is up and this is down. And the letter we're going to use is the letter K. And it's always in the same direction of the sign. So if I'm going to use my general form here, this moved it horizontal. So now I'm going to move it vertical. So that's the plus K. So then that means that this function then gets transformed. So if I'm going to go down 5, that means it's going to be in the same direction, so I'm going to put minus 5. So this one here, this was my K. The next transformation that I'm asked to do is a compression of 1/2. So when we look over here at the compression stretch reflection, so there's a number of things. So a compression is when we have some number a that is a fraction between 0 and 1. A stretch is some number a that is bigger than 1. And a reflection over the x-axis, which I'm going to abbreviate ROX, is when a is negative. Okay, when a is a negative. So we're going to do a compression here. So going back to this format that I have here, our compression would be our a, and that gets multiplied to our function. So you can see we're doing more and more to our parent function as we go along here. So if I want to show a compression by 1/2, that would mean that I would have to do 1/2, where that A is, times whatever my function is. So this is going to be +3, and then I'm going to have -5. I might as well write that in red. Okay. There's one more thing, though, because we have a reflection over the x-axis. So to have a reflection over the x-axis, my A must be negative. That means that this is going to be -1/2 times my function form, whatever that is, -5. So if I want to take my function, I want to transform it so it shifts left 3, down 5, compression by 1/2, and reflection over the x-axis. This is what my general function would look like. All those things happen there. So now that we looked at it generally, let's look at it with a specific function. So here I'm looking at something that's cubic. This is my parent. This is a cubic function. So let's do our horizontal first. So my horizontal, I'm going to take my cubic, which is x cubed. And what am I going to do? I'm going to go right 2. So I'm going to take the opposite sign. So instead of a +2, this is going to be a -2, because that moves it right. Then if I want to move it up 4, I'm going to take this function that I had, and I'm going to move it up 4, which means I'm going to go in the same direction. So this is going to be a +4. Then it asks a stretch by 3/2. So that is my A position. So my stretch is 3/2 times x minus 2 all cubed plus 4. So that is what my new transformed function would look like. We have our friend, the quadratic. I know it's a quadratic because it's square. So let's do our horizontal transformation left. So that's going to be x. So the opposite of left would be a +5. And my function's a quadratic, so that has to be squared. Now I'm going to move up 5. So I have x left 5, and then up 5. This 5 happens to be my vertical. And then I'm asking to do a stretch by 4. So that would mean my A is 4. And then I still have my x plus 5 plus 5. And then a reflection over the x-axis. So the reflection over the x-axis means I need to make this a -4. So those are all the transformations that have happened there. So lastly, I have a square root function. We've not looked at this one before, but the same rules apply. So this is a square root function. So notice my grouping symbol is a square root. My x is under the square root. So my transformation left or right happens under the square root. So this is a right one, so the opposite of right would be -1. And then I want to do the next transformation. But make sure that -1 is under that radical. So I have my right one, which is x minus 1, and then I'm going to go down 3. Down is vertical, it's outside the parentheses, so I'm going to have a minus 3. And then I want a reflection over the x-axis. So I have my square root of x minus 1, and this negative 3 is outside the radical. So remember, a reflection is nothing more than a being negative. I could put -1, or I could just simply write negative. So those are all the transformations that we can do to our functions. And if you notice that the form is always the same, no matter what type of function you have.